Good evening, everyone. Am I audible? Okay. Yeah. So today it's a revision session. Okay. So I'll be covering week 1 and 2, and then we will solve a PYQ. So I'll start with week 1. So this slides you'll see in that particular drive link, Java revision slide. So in week 1 we started with the introduction to the course itself, right? And yeah, oops, exception handling, everything will be covered in this. I'm skipping this part. So the important part is types, static typing and dynamic typing. So types have many uses, like it is used to make sense of how the number of bit sequence in memory, so that we can conclude on how many bit uh, will point to some kind of data types, like, so that is what static typing. In Java we will specify the data type, we will declare the data type, and then we will use it. And for dynamic typing, it means that the data type will be inferred from the value that we assign to it. And there are many advantages for static typing, like helping the compilers to catch the bugs early while compilation, after compilation. And then also we can also optimize the code. So those things. So here it is given this example where some programming language like Python, where they infer the data type from the value assigned to it. So x equal to 7, and then if I write y equal to x plus 15, then y must be an int, because here this will be an addition operation, that x will take an int value 7 plus 15, and it won't be string concatenation. So that is what reducing the type from the value that we assign to the variable. And then we have discussed about memory management, right? So in memory management, we have seen the terms like scope, lifetime, etc. So scope means, scope of a variable means whether we can access that variable, right? And lifetime means whether the storage for that variable is still allocated or not. So we can relate this with the activation record for the functions that we create also. So what is activation record? For each function call, an activation record will be created, and we'll put that activation record into the stack. And this activation record will contain some information like the variables and all, and also this return value link and control link. So what is the specialty of control link? What is it used for? It is used to point to the previous activation record. Suppose we are having some recursive call, like the example that we have discussed is about the factorial, right? So from factorial of 3, we'll call factorial of 2 and 1, right? And the result of factorial of 1 we have to give to factorial of 2, right? So for that we have to first connect one call to another call. So control link from factorial 1 will connect to factorial 2. So it will point to the previous activation record, so that we can come back to the call, the one which called the first function. So this will be used to trace back. And return value link tells where to store the result of that particular function call. So that is the use of these two. Then,
Ma'am, one question
mm,
about activation records.
okay,
So the question goes like this: that if say this function like call to n equal to 2 and n equal to 1 calls n equal to 2, or n equal to 2 calls n equal to 1, for whatever. So once that particular operation is done, then the activation record is like in the stack. It stays off the stack. How does it happen?
no, no, it will be removed.
And
It
ma'am,
will be removed. Yeah.
what are the things that call create activation records,
What are the things that
create these activation records? I mean,
whenever you call a function, yeah. Suppose we have this factorial function. Okay, and when you call factorial of some 3, now for this particular call, an activation record will be created in the stack.
I get it, ma'am. You mean to say whenever a method is called, be it
Right.
public, be it in within an be it wherever, right, ma'am?
Yeah.
If we call the main method, then also an activation record
They
is,
will be created. Correct. Yeah.
but it won't stay, right? Because once the main method is active, the activation record of main method is created, does
Mm.
it stay? Does it stay as long till the lifetime, or like it's gone as soon as the main starts?
As soon as the main starts, an activation record will be created, and at the end of the main, then it will be popped out.
No,
So if you have to, yeah,
if the main goes to some call some other methods in the, I'm just talking, I wish I had a code to support this, but I'm talking hypothetically, ma'am. There could be
can
one
you?
2023 or 2024, I think. Yeah, 2025, in fact. January 2025, there was one code.
This one, not January, huh? Okay, wait.
It was in Jan 2025, ma'am, I think. I remember seeing one. Yeah, this one.
So this one, right? 23 Feb. This one, right?
Yeah, I think.
Okay.
Yeah, this one.
Mm. So what is your doubt? Like,
4 or 5.
okay. Here though, yeah, let's focus this question uh, while sitting in week one. Okay, so we assume that you are not yet introduced to this classes and objects. So here the constructor call has not included. Okay, so for example, okay, let me go through this code. Class 1, we have method 1, method 2 calls method 1, method 3 calls method 2. In class 2, here is our main method, and class 1 we are creating an object, and using that object we are calling method 3. So first, for the main method, an activation record is pushed into the stack, and then method 3 we are calling method 3. So for method 3, second one, we are here. From method 3 we are calling method 2, third one, and we reach here. In method 2 we are calling method 1, fourth one, we reach here. So from here, the normal execution of method 1 will happen. It will get popped out. Anyway, now we have got 4 activation records, right? So the answer is 4, this one.
So you're saying that method 3.
Mm. Main method, method 3, method
No,
3
no,
calls
ma'am.
method
The
2.
new class 1, the object is being created, ma'am.
This constructor call we have not included.
Why?
Only the method calls have been included,
Why, ma'am?
because uh, we stick with week one. That is the reason. And also, if you include this constructor call, we have to include the objects constructor call as well, right? So that will be 6 in
Okay,
total.
okay, ma'am. For all quiz one questions, we will just stick to method
Huh,
call.
right. And as this confusion arised, nowadays we are avoiding this kind of questions. Like this constructor call, few people get confused with this, right? So we make this methods as static methods and then directly call it, so that you don't have this confusion of creating the object. This constructor call won't be included over there.
Okay, ma'am. Thank you.
It is not
But
the
but ma'am,
Mm,
in discourse, the same discussion happened. They are
mm,
including construction,
mm, mm.
constructor code.
Yeah, technically, actually, if you get the what stack trace, you will see this constructor call is included, right? That is correct actually. But as this question coming from week one, we have not included that. So our correct option was 4 when we released this question.
ma'am. Sorry, ma'am. One question. How did you
Mm.
get 6? 4 for the method, 1
Huh.
for new class 1. Where is the other one? Object class, huh?
Object class. It extends object class, right? So the constructor called from that object class. But for now, you just keep it just with the methods, normal methods. Don't include constructor calls.
Okay.
Yeah. Okay, so next part we have seen this call by value and call by reference, how to initialize the parameters of a method. So in call by value, you pass a copy of the value, and in call by reference you pass the reference, copy of reference or reference itself, which means both will point to the same location. The object or the variable will point to the same one, and whatever the changes that you make inside call by reference in that particular method, it will reflect on the original variables as well. And call by value, you won't see any side effect because you give a copy of the value. And then we have seen heap memory, right? So heap memory is used to store dynamically allocated data that you create at runtime. And the specialty of heap is it outlives activation decoder function, which means if you create some object in a method call, so after the method exits, then the activation record will be popped out, but the object that you create in the heap will still remain in the memory, heap memory. And this is about deallocating heap storage. So this is a concept. So explicit deallocation is there, and also automatic garbage collection. It's up to the programming languages. Like in Java and Python, we have automatic garbage collection. In C programming, we do explicit deallocation using some methods. So those have been discussed for heap memory. Yeah, that's about stack and heap. Just focus on the terms that we have used over here, like scope, lifetime, what is scope. This is just like, yeah, you have to remember the terms and all. Maybe you will get some MCQ or MSQ related to this. And control link, return value link. Yeah, those things. That's enough for exam point of view. Yeah. Fine, right?
Yes, ma'am.
Okay. Then we have abstraction and modularity. So here we have seen about top-down approach, right? So if we have a problem in our hand, what we do is we'll take the problem and we will divide that into smaller subtasks, and we'll solve all those subtasks and combine it, which will come together as a system, proper system. And bottom up is we have not discussed in lecture, right? Here though it's opposite. We start from the bottom level. We will build small building blocks and combine to form the bigger version. And then we have seen these terms, interface and specification. Like for each component, we will have this interface and specification before going directly into the coding. We have this design part, right? So interface means you can, yeah, now though you already know about interface, right? The functions that we have seen, where we have the function name, the return type, the arguments, so that we can call it as an interface. And specification is what exactly that particular function has to do. You can write it in some form, right? For example, if you want to, if you are writing some program and a function to play some order, like order, then you will write what kind of things you have to do, some step-by-step instruction, input and output of that particular function. That is specification. Build prototype implementation to validate design. Prototype means a model, a template for what you are going to design, develop actually. So this is a design part. Re-implement the components independently, preserving interface and specification. Later on, once you have the interface and specification, the design part, you can move this into the development side. Programming language support for abstraction. So next term that we have is this abstraction. So abstraction means what? We are hiding the implementation details and showing only those details that is necessary for the users to know, or yeah, anybody. So in case of any program, we have two parts, data and the program itself, the control flow or something, functions we can say, data and functions. So for control flow, we have functions and procedures, the same anyway, methods. And data, for data itself, we have abstract data types. The class can be called as an abstract data type, right? And other classes like stack, queue, all those things we can call it as abstract data types. Then we will see about object-oriented programming. So just listed those here. So here you just focus on the term modularity, where we we will divide the task into smaller subcomponents, modules, and then interface and specification. Yeah. Okay, that's it. Is that okay? Okay, then next, yeah, from here, we started with object-oriented programming concepts, right? We have seen what is an object. Objects are like abstract data types, right? And here we will combine data and functions into a single entity, that is classes or objects. Now, distinguishing features of object-oriented programming, the OOPS concepts. So we have seen abstraction. In abstraction, again, this is like repetition. Public interface, private implementation, like abstract data types. Then we have subtyping. Subtyping, this we can now relate it with the interfaces, right? One type and subtype, where the subtype will be specialized type of the supertype. And hierarchy of types we have seen. You can relate now with the examples that we have seen so far from week 1 to week 4. Then we have dynamic, yeah, here just remember this term compatibility of interfaces for subtyping. So why we say this compatibility of interface? Anyone?
If A is a subtype of B, then if I need an object of uh, type B, I can get it through the object of A.
Yeah, right.
I cannot do the vice versa.
Yeah. So you can just think it in terms of employee manager types, and yeah, you can have something like employee is equal to new manager, same thing. So focus on the terms here again. And next is dynamic lookup. Dynamic lookup, what was that? We have discussed this many times.
Same example, no, ma'am. Employee is equal to new manager. So though I would have defined the A as employee type as is equal to new manager, when I'm doing new manager, dynamically it will bind it to the manager class.
And so suppose we have a method that is defined in employee, like bonus method, and if we override the method in manager, right?
Yes.
And in this case, which bonus method will be taken at runtime? That is decided by the type of object at runtime. Correct?
Correct. Yes, ma'am.
Yeah, that is dynamic lookup. Choice of method implementation is determined at runtime. Runtime type of object.
The dynamic lookup and dynamic dispatch are the same thing.
Yeah, that's same thing. Dynamic lookup, dynamic dispatch.
Okay.
Yeah. Then we have seen inheritance. Inheritance, reuse of implementation. So if you have a class, if you want to add some more things to that class and use it, then you just uh, extend that particular class and add more variables or methods that you want. So we are basically reusing an existing implementation. So these are the features of object-oriented programming that we have discussed in our course. Yeah. Next, we saw what is class, right? What is class? Like if you are focusing, I think now you know about these classes, objects, and everything, right? These concepts and all. In code point of view, I think you will be knowing well. Why I am stressing over the fact like that focus on terms is if you are getting some theoretical questions, there you have to answer it right properly. That's why I'm focusing on the terms. Okay. So class is a template. We can call it as a template. It will be describing instance variables. The variables we can call it as instance variables. What are instance variables? What is the difference between instance variable and a static variable? Anyone?
instance variable or for the object? Static variable,
is
you don't need the object.
it is accessible for all the methods in the class.
Which one?
The instance variable.
Sure. Instance variable is like, for example, if you have class employee and if you are defining int roll number, int salary, and if you have some static string name of the company, now say which is instance variable and which is static variable and what is the difference?
Ma'am, please repeat the question.
If you have, okay, I'll just. Now tell me, which is instance variable?
Salary is the instance variable.
Yeah, it's very obvious here because I have given static. And which is available for all the objects?
Salary.
Both of them actually.
As a common one?
No, ma'am.
Name of company.
This is common, right? So this is static variable, which means this is common, and this is like individual copy. Each employee object will get an individual copy of salary. So this is instance variable. Instance is object variable. This is class variable, static variable. Okay. Yeah. So describing the instance variables and methods for an abstract data type. So we can call a class itself as an abstract data type. Now, an object is the concrete instance of a class. Concrete instance. So here we say class is abstract data type. Now the opposite of that is object. Object is concrete instance of that class, which means it has some values for each variables and all. Now we should separate the public interface from private implementation. Yeah, that we have seen. Hierarchy of classes to implement subtyping and inheritance. We have seen that. Then, yeah, talking about the private variables and private methods and all. So the private keyword itself. So we can make a variable as private variable, which means it won't be accessible from anywhere outside that particular class. Okay, we have seen other access modifiers as well: private, public, default, protected. Default in the sense no modifier. So that is discussed over here. Now, yeah, that's about week 1. Okay, just for some interaction, I'm going to some PYQs. Okay, I'll solve some question and we'll come back to the theory part again. That will be fine, right?
Yes, ma'am.
Okay. So see this question. Consider the code given below. How many activation records are created while executing this code? So class 1 has these methods: method 1, method 2, method 3. In method 2, we are calling method 1 and method 3 is calling method 2. And class 2, we have this main method. And here we are creating an object of class 1 and calling method 3. Okay, we'll start. So whatever the methods that we are seeing, we'll consider only that for the activation record, counting the number of activation record. Okay. So the main method, here we have main method. And then we are calling method 3 here. So we reach here. From method 3, we are calling method 2. So 3. And we reach here. From method 2, we are calling method 1, which means 4. In method 1, we will exit. We'll come back here. Then we'll come back here and we'll reach back here. right? So we got 4 in total. So number of activation record while creating this code is 4. Right answer. Fine, right?
So in that question,
Okay. Sorry.
can you please go over that question once again?
Okay. Consider only methods for activation record. Okay. Don't consider constructor call and other things. Just consider the method calls. So first we have the main method. Main method anyway JVM will call. So main method. Then we are calling method 3 from here. So that is 2. Second activation record. From method 3 we are calling method 2. Third activation record. From method 2 we are calling method 1. Fourth activation record. From here we will come back. We'll exit each one and we'll come back here. So anyway in total we have created 4 activation record for the methods.
Right. Okay, understood.
Yeah. So this was my plan actually. I'll come back to this question paper. So consider the following Java program. Here again this is a similar question related to activation record. Okay. When the call stack reaches its maximum depth, which method will be at the top of the call stack? Question is different. Which method will be at the top of the call stack? Look at this class example. Method A, method B, method C. Let's go to main method. From main method we are calling method A by passing 3. Now in method A we have x as 3, okay, and 3 greater than 0. If 3 greater than 0 then call method B by decrementing x. So 3 minus 1, 2. Method B of 2. We reach here, y is 2. If 2 greater than 0, yes, then method C of 2 minus 1, method C of 1. We come here, z is 1, 1 greater than 0. We are calling method A of 1 minus 1, 0. We'll reach method A back with x value as 0. And here, x value is not greater than 0. So we will trace back, right? So at the top of the call stack, which method will be at the top of the call stack now?
Method A, no, ma'am. Method
Yeah,
A.
right. Method A.
So, ma'am, we are calling method A with the value 3. In this
Right.
case, and the if statement says if the okay, okay,
Yeah.
Ma'am, can you repeat my whole thing?
Yeah. You focus on this. We have 3. Okay. First we have value 3. And every time we call a method, it's decrementing. Okay. So we call it with 3, x equal to 3, x greater than 0, true. Method B of 3 minus 1. Now here method B of 2. Now value of y is 2. Okay. 2 greater than 0. Method C of 2 minus 1, 1. So method C of 1. Here also we have reduced y by 1. So we got method C of 1. And here 1 greater than 0. Z value is 1, 1 greater than 0. Method A of 1 minus 1, method A of 0. Now x value is 0. We come back here because we are calling method A, right? So here in the if, we are not entering into this if block. So we'll exit. So at the top of the call stack, we'll have method A. Now look at the question. When the call stack reaches its maximum depth, which method will be at the top of the call stack? So that is the maximum depth. Clear?
yes, ma'am.
Okay. Now consider the Java code below. Choose the correct option. class account, it has a method called login, a return type of void, and printing basic login. Class user extends account. So this is the subclass of account. Here we are overriding the login method. See the sorry, here I kind of highlight public void login. Here also public void login, right? We are overriding, and inside the login method we are calling super.login. So this will call the login method of account class, right? After that, what we have print user login. Now next we have another login method, and this login method has some argument string code. So this is method what overloading, right? Yeah. So after taking in this string value, it is going to print user login with code, whatever the code that we give here while calling the login method. So that is about two classes. Now we have another class admin. Admin extends user class. Okay. Now here it is calling, it has a method login. Login is calling super.login, this one, because admin is extending user class and then printing admin login. Now we have another login method, overloaded login method, which takes code and printing admin login with code, whatever the code. Okay, just remember the structure. We have a class account, user extends account, user is subclass of account, and then admin extends user. So admin is subclass of user. Okay, so multi-level inheritance. And then in class test, we have main method. Here we are creating obj of type user. Look at user. Okay, this one. And object is of type admin. Okay. Now calling obj. So here we have a line 1 marked as line 1. Then obj dot login. So object is of type admin, right? And let's see like this. Let's see how the compiler will process. So obj is of type user. It will go to user, right? And it will check whether it has a login method or not. Yes, it has. So compile time check passed. Then let's go with the compile time check for the next one. Obj.login with quadruple 9. Okay. Then we come back to user. User has a login that can take some string value. Okay, fine. So compile time checks. So compiler check is fine for this code. Correct? We have not seen any error, right? Here also no error. User obj equal to new admin is also possible. Now let's come back to the runtime part. So in runtime, what will happen? Obj.login. So the object is of type admin, right? So we'll go to the login method of what?
Admin.
Admin. And in the login method of admin, we are calling super.login. So that will call this login method. Here again we are calling super.login. So that will call this login method. Correct? And we'll print basic login. We'll come back, user login, come back, admin login. Okay, that is for this line, right? And next obj.login with this string. We'll come to admin and we'll print admin login with code 4 nines.
But ma'am, it will be up to user level because the variable object is of type user.
Yeah, but these methods are available in user, right? So no issues. Getting. So we have login here. We also have login in user. We have login with string code. We also have login with string code in user. We are basically overriding. So as that is the case, we don't get any issues. With obj of type user, we can access the login method.
Yes, ma'am.
Ma'am, ma'am, one question. What if it was instead of user of obj had been account obj?
Account obj still, then we'll be having issues for the second here. This will create a compiler issues, compiler error, because we don't have a login method with some argument, right?
Ma'am, what would be the output?
Compiler error. We won't get output.
How so, ma'am?
Mm.
Ma'am, how so? How will he get a compiler error?
So see, account obj equal to new admin. Then when you reach this line during compilation check, during compiling, what will happen is you will get this error line, some line number will generate compilation error because that particular method is not available in class account.
But ma'am, if the code is up to,
Mm.
if it is the variable is up to that level,
Wait,
yes.
I'll show you because this will take a lot of time if I start typing. I'll just take the code.
Ma'am, can you please go full screen
Yeah.
in the compiler, in the GDB compiler? No, ma'am, if you please click
Mm.
that, no, that not that, beside the gear sign, ma'am.
Gear sign. Where is it? Yeah,
Below, ma'am,
here.
below, not there, below, ma'am. Command line arguments beside the gear sign. Not this one, yeah, this one.
This one. Okay, fine. So, okay, here it already gave account. Okay. Uh, yeah, we'll also add login with some string. What is same, right? Method login in class account cannot be applied to given types because here you see A1 is of type account and account doesn't have a login method of this type. Clear?
Clear.
Okay. Someone wanted something else also.
Yes, ma'am. I was asking that if it is accessing up to the user level, how is it printing the admin login? I mean, the variable is up to the user. I mean, A1 is a type of user type, right?
Okay, you're asking when A1 is of type user,
So then how is it accessing I mean, printing the admin login?
admin login. Oh, okay.
Should print up
So
to,
yeah, I got your doubt. So look at the object. Object here is admin, right? Object is of type admin. So during runtime, when you call the login method, it will go to the nearest one for admin. So that is this login method, whatever login method that is present in admin itself. Okay. Now this login is going to call super.login line number 8, and from here again super.login, then we'll reach here. That is how the chaining is happening. Object is of type admin. Okay, so we'll come to the login of admin itself, and here we'll go here and then here. So while printing, we'll start with basic login, then user login, then admin login. All because the object is of type admin.
Okay, ma'am.
One question here.
Hmm.
If user did not have a function admin, then
User did not have a function.
if the user did not have a function admin, then to execute line number, you just scroll down a bit, ma'am. Scroll down a bit, please. To execute line number 32, we either have to typecast or it would have thrown an error, right?
Wait. You are saying this user won't be having this login method.
Yeah.
Then no, we don't have to typecast. Oh, okay. Then okay, we are our object is of user, right? Then we can't access. Typecasting is needed. Yeah.
So, ma'am, what I'm saying is that
Mm,
in the if the reference type is of user and the
mm,
object type is of admin,
mm.
so whenever we are trying to execute line number 32, shouldn't it be directly printing line number this going to line number 8 before going to line number 19?
Wait. So for now you have login method in, correct?
Yes.
Okay. Now you
And
are calling.
line number 32. So if
Mm.
I'm calling line number 32, and since the reference type is of user
Okay.
and the this object type is admin, which is
Mm.
so to execute line number 32, shouldn't this go directly to line number 8 rather than
No,
not
no,
go to line number 19?
no. See. Look at the object. Object is of admin. So here, go again with the dynamic dispatch. Same concept. Object is of type admin. Now in admin, so in compilation, we have already seen that this is totally okay. We can call login method, right? And now in object of admin, it will check whether we have a login method in admin. Because our object is of type admin, we'll check whether login method is in admin. So this is the closest call, right? Only if this admin doesn't have a login method, it will call the login method of user. Otherwise, the importance is for the login method of admin itself because the object is of type admin. Okay.
Ma'am, is it
It
possible to
won't.
run the code uh, by run the code as it is? I think it should run.
Yeah.
Basic login is coming from where?
From the top. From here.
Okay, user login is coming from.
Here.
That's because we had the super, right? Super is
Right.
calling everybody.
Yeah. Super is calling the super class. The
But
parent class.
is it possible to comment out the super and see what happens?
Okay. You don't want super call here, right? Here. Okay. Then this login method.
No, since we don't have an output, I
Wait. What happened? Wait. Let me check. It should come. Yeah. That's what I was thinking. I think that was just compiler issue. Thing is, this should work. Like when you call a1.login, this login method of admin, here it should print admin login. Okay. And now we don't have any relation with the previous login methods of the super class, right? And next login, we are just getting admin login with code.
Thank you, ma'am. Thank you.
Yeah. So I think the concept of this chaining is not clear for you guys. So when you call login method, okay, now our object is of type admin. So go to the login method of the admin class itself. Okay, don't go to the super class. Look at the object. Object is of admin. Go to the login method of object, the same class. Okay, from here you see the relation. So when you call super.login, this is going to take you to the login method of the parent of admin, that is user. So from here you are calling again super.login. This is going to here account class. So we'll print basic login. We'll come back. Think it of like we have created an activation record for this call and it got popped out. We control link is pointing to the previous call, right? This login method. So we will reach this point. After this line, correct? And after this, we'll exit this particular function also, and we'll come back. The control will come to wherever it got called here. The next line will get executed, admin login. And then we'll come back to line number 32. You got that structure, the chaining?
Yes, ma'am.
Okay. Now, look at other options also, incorrect options. Line 1 generates compilation error because a variable of type user cannot refer to an object of type admin. So user obj equal to new admin. So it is saying that we will get a compilation error, which is wrong, right? Because admin is of subtype of user. This particular line is correct. The output is basic login, user login with code. Here, this admin login is not printed. Here, the next one output is basic login, admin login, and then, okay. Here, we have skipped this user login part. Moving on to next one. Okay. So, class animal. Here we have a private variable name. Then we have a constructor that takes in and assigned to name. Here we have a ToString overridden that is returning name and then the name. Now class dog extends animal. Here we have a private variable string breed constructor here that takes two arguments n and b. Line 1 we don't have. Line 2 assigning b to breed. Then we have ToString method calling super.ToString. So this one, right? And then breed and printing breed. Okay, then go to class test. In main method, we have animal dog equal to new dog with Rocky and golden retriever. Printing dog. Yeah, any doubt? Okay. So the question is, choose the correct option to be filled in place of line 1 so that the output is name Rocky, breed, golden retriever. So this program should print this particular line. For that, what we have to fill in the place of line 1. So here, this is the constructor, right? And if you see the name, it's a private variable. So how can we? So this n should be assigned to this name. So that is our goal. So what we have to add here?
Super of n, ma'am.
Super of n. So super of n will go to the constructor of the parent animal and assign name equal to n. Is that
So
okay?
in this case, ma'am, in this case, we are calling super with the reference by value or reference by address.
So We can say it's a string, right? So it's a reference.
Okay.
Isn't everything in Java called by address?
Not everything. For primitives, it is not.
Ma'am, how you said this super, ma'am?
So to call the super, so to call superclass methods, you have seen this super dot, then the method name, right? So this is a super keyword. And when you have super and then opening braces and closing braces, it's a constructor call to the superclass. So here if you see super of is a method call, constructor call, and when then passing in. This is syntax only. This is how you can assign or instantiate or add value to a instance private instance variable of superclass. Here name is private, so we cannot directly access it. So we can assign this n to name by calling super of n. So that will call this particular constructor animal with n and then assign n for name. Clear?
Ma'am, one small doubt, ma'am. In
Okay.
system.out.println, you're doing dog. Should it not be dog.toString? Or we can.
So this will automatically call dog.toString. So you don't have to
Okay.
specify it.
Specify.
Even if you specify, no issue.
But the system.out.println will automatically convert it to .toString. Okay, it will call the objects toString, but as we
Huh.
have. Okay, I got it, ma'am. Thank you.
Yeah. System.out.println dog.toString. It is similar to that. So here this toString also we are calling super.toString. So that will call this toString. So name equal to Rocky, and we'll come back. We'll add with breed equal to golden retriever. So what is this is used for?
This, అందుకే నువ్వు డమ్ పాప అంటున్నావు.
What is this used for?
To
Object.
indicate the current instance.
Huh. So within the class, if you call this, you can call this constructor of that particular class itself, right? So if you have some other dog, yeah, with some one argument, and there you call this of n, then you call that constructor. Animal of n anyway not possible. Super dot animal of n is not correct. Okay, look at this question. Switch test related to using switch. Okay.
Ma'am, what is wrong in option D? In before question.
Option D is completely wrong, right? So we don't have something like this. You can't
Okay.
call constructor in this manner.
Okay, ma'am.
So when you call super of n, in English we can simply relate to like this: super dot animal of n.
Okay, so if we specify the name of the constructor, that's wrong.
Yeah. You don't need to. So the syntax is you just have to pass the arguments. So if you pass one argument, then that will call the what constructor with one argument. And if you
Okay.
pass two arguments in super of n comma something else, then it will call. And if you have a constructor with two arguments, it will call that constructor of
Okay.
animal.
Okay. Understood. Thank you.
Yeah. So in switch test, we have a for loop here running from I equal to 0, I less than 3, I plus plus, so 0, 1, 2, right? The values of I. Switch I, so the cases are case 0, print 0, break, so not print ln, okay, just print. Then case 1, print 1, and then we don't have a break. In case 2, print 2 and a break. Default, print default. Finally, we have a println. Here in main method, we are calling the static method show. What will the what will be the output? Just trace for I equal to 0, case 0 will print 0, right? And then here we have a break. So we'll come out of switch. And then I value will become 1. Case 1 will print 1. We don't have a break. Then what will happen?
It will print 2.
It will print 2. And in 2, we have a break. From here, we'll come out of the switch. So what we have currently? 0. Okay, here we have not added this println, right? So after 0, we'll go to next line because of this println statement. And in the next line, we'll have 1 and 2. 1 space 2. Then we'll print a line, go to next line. Then I value will become 0, 1, 2. Case 2 will print 2, break. Okay. So the output will be which one?
First one, no ma'am. 0, 1, 2, 2.
A, ma'am.
Correct.
When
First
will
one.
default be called, ma'am?
When if the I value is other than 0, 1, 2, default will be called. In our case, it won't.
In this case, it will never be. Okay.
Never. Yeah.
No, had it been like I less than equal to 3, it would have probably hit.
Right. Okay, see this one. Consider the Java program below. Choose the correct option to fill in place of code block so that the output is viewing balance, calculating interest for savings account, offering premium benefits. Class account, we have void view balance, printing viewing balance. Savings account extend this account class. Here we have a method called calculate interest, calculating interest for savings account. It will print that. Then we have premium savings account that extends savings account, and it has a method offer premium benefits, and it will print offering premium benefits. Then we have bank app main method, creating an reference variable SEC of type savings account, this one, and object is of type premium savings account. Okay, we have two calls. One is to view balance, the second one is to calculate interest. Here we have to add a code block for what? Yeah, choose the correct option to fill in. Yeah, we have to get viewing balance, calculating all three strings.
And we have to go to each of the parent classes.
Yeah, you see from here. So ACC is of type savings account, right? Okay. Now look at the capability of savings account. From savings account, what we can access? Savings account extends class account. So savings account can access view balance, right? And savings account has its own method, calculate interest. Correct? So ACC, using ACC, we can call view balance and calculate interest without any typecasting or anything, just by ACC. So this is fine. Now for this particular statement to be printed, we have to call offer premium benefits. And using ACC, as it is of type savings account and as it doesn't have this method called offer premium benefits, it cannot call directly. ACC dot offer premium benefits won't work. What we have to do then?
Premium savings account, ACC, enclose them in brackets and then call the offer premium benefits.
Correct. We are basically typecasting ACC to premium savings account and then we can call. So which one? Third one.
Option here.
Yeah. Typecast ACC to premium savings account bracket dot then the method call.
Ma'am, my doubt is if you don't typecast, we'll get the compiler error itself, isn't it?
Right, right.
Okay. If to solve, but otherwise, if that compiler error is not there, you can automatically call, right? Premium savings account.
Yeah, but we will get compiler error. Why?
Compiler error.
Because using ACC as it is savings account type, you cannot access offer premium benefits directly.
Yeah, the problem is that if there was a offer premium benefits method when declared and defined in savings account, then
Yeah,
we would have had to do the typecasting because it would have printed from there.
correct.
Yes, got it. Yeah.
Ma'am,
Mm.
but if we follow the practice like ACC, we declared it as savings account,
Mm.
but we know that premium savings account is the really
The object.
good type of object having access to all the methods.
Mm.
So why not have the practice of declaring ACC as a premium savings account itself?
Yeah, I understood. So this is actually learning process, right? So we are doing this, but this application will be useful when we have an array of savings account, and there if we have multiple classes that extend savings account, and then if you have to call a common method, you will see some example over there. I'll show that. I think in this QP itself we have a question like that. So that is the
Okay.
main motive. So in this example, you can say we could have uh, created ACC of type premium savings account itself, then we would be not having all these issues. Correct, yeah. But now you have to focus on this. You will get a lot of questions like this. Uh, so testing your understanding about the capability of each type.
So just leaving, I mean, he raised a very good point. So just for coding purpose, the good
Mm.
practice, we should always declare the reference type to be that of the subtype. Like premium savings account ACC equal to new premium savings account, so that we can access all the other previous methods.
It's up to the requirements. Suppose if that is not the case, for example, let's have a scenario in the bank itself, something similar to this, where uh, you will be having different kind of accounts like this, okay, and you want to call a common method on all the type of objects that you create from different classes, okay. In that case, what you can make is you can create an array of account itself, right? For example, an array of account itself, and then you can call view balance on all the objects of different types, savings account or premium savings account. So each element of our account array can be any type, and it can call the view balance method. Any object of any classes can call the view balance because the main type, our array is of super type. Getting it?
I think I'm getting it, ma'am. Okay, ma'am. Thank you, ma'am.
Yeah. Maybe I can extend account. We are creating an account array of 2, size 2. Then one of the element will add savings account object, other element will add premium savings account, and we are going to uh, have a for loop for I in this particular account array. We are going to call for each I call view balance method. So as both savings account and premium savings account has an access to view balance, we can just run a for loop and get it done instead of repeating the code.
Yes, ma'am. Understood. Thank you.
Yeah. So okay, next one. No problem, right? I am continuing because now you are familiar with week 1 to week 4. So I'm continuing with this paper. Or should I go back?
No problem, ma'am. For me, no problem.
Okay. So all these are same only, inheritance. Even if we are discussing about interface, it's another kind of inheritance itself, right? We just have some syntax, keywords and all. That's it. See the interface printable. Printable has this. What is this method? Is it a regular method?
It's an abstract method.
It's an abstract method.
Yeah.
So print is an abstract method. So whichever classes that implement this interface has to give an implementation for the print method. Now class book implements printable. Now for print method, it is giving some implementation printing book. Then we have class magazine that implements printable, and here it is overriding print as printing magazine. Now, yeah, I think this was what I wanted to say earlier also. Print queue, we have class print queue, and here we have an object array. I hope you remember what is object. Object is at the top of the class hierarchy. Whichever class is book or magazine, it is by default inheriting this class object. So this is the topmost class in that particular tree. So object array printables. Now as it is object array, now it can hold book, magazine, anything, right? So it has new book, one object of book, and another object of magazine. And then we have a method start printing. For int I equal to 0, I less than printables dot length I plus plus, basically looping through this array. Something we should do here in line number 1. Print test main method, creating an object of print queue, pq dot start printing. We are calling the printing method. What is the question? Identify the appropriate option to fill in place of line 1 such that the output is printing book, printing magazine. We have to get printing book from class book and printing magazine from class magazine. What you have to fill here? We have to call the print method for these two objects. Object array is of type class object. So what we can do here? What can be inserted here to call the print method of both classes? Okay, I don't want if and else part. So a single line. We have only one line to fill here. So anyway, we have to call the print method of that particular array printables of I dot print, right? Do we have to
Option
do
B,
anything
ma'am.
more?
Printables of I dot print.
Okay, why so?
Because it's an printables of I will give you an object of class object. So that you typecast it to printable, which is an interface. From that you call the print. That
Yeah. So printable has print method, and both book and magazine are implementing printable and has overridden the print method. And now we have a common interface or the highest type, right, for book and magazine. So you can't directly call the print method, right? Because the array is of type object and object doesn't have a print method. So we have to typecast into printable and then call the print method. So option B is correct. Is that okay?
Yeah, ma'am. If you can please explain that last class, public class test print. What is it doing?
Sorry, which line? Public?
Public class test print.
Okay, okay.
This
Ha, ha.
class. What is it doing? Whether
It's just creating an object of print queue and then calling start printing method.
it's creating an object print of class print queue.
Yeah.
And
See? So you can think it of like we have these many classes: book, magazine, print queue, and now in print test, this is our main class. We have the main method over here. Here we are creating an object of print queue, pq, and then pq dot start printing. We are calling start printing method of print queue using the object pq. Instead of putting this here, this is separate in a separate class.
ma'am, just for I'm sorry, I'm just taking probably a couple of minutes here. If I have to go with the program flow, it begins with the main.
Yeah.
Ma'am, if you just can walk me through which steps happen when in this code. Like
Okay,
first,
we'll start from main.
yeah,
Then we'll create print queue object. Object is created. Then we'll call start printing. From start printing, we'll see this.
no, ma'am. When does this the line private object printables equal to the array is initialized? When does the array get initialized?
So when print queue object was created, this will get initialized.
Okay.
Okay, you are saying so. This is just like some instance variable with some value that is already assigned. Clear?
Okay, ma'am. Okay, clear, ma'am.
Yeah.
Thank you.
Yeah. Okay, this one. So here we have interface shape, and you know about default methods, right? Default methods in interface will have a default implementation. Public default void row printing drawing shape. Then we have class circle that implements shape. Line 1 we have marked it, and circle doesn't have any methods or anything. Then we have class square. Do you see any problem in this particular class definition?
Yeah, it should have like shouldn't have been mentioned as abstract or something.
Mm,
It's not like
so
it's not giving any method. It's not declaring. It's implementing shape.
yeah, but this method is a default method, right? So let's
Okay,
see.
so
Yeah.
so shape has already got no abstract methods, and
Huh.
since everything has been taken care of in the shape interface itself, and now that
Yeah.
circle is free to implement shape without having been declared itself as abstract. Is that what you?
Correct. Yeah.
Okay, got you, ma'am. Thank you.
Then here class square implements shape. So here it has given a new definition for draw method, drawing a square. Okay. Now in class drawing test, main method creating an object of shape, I mean reference of type shape, object of type circle, s1 dot draw. Circle, it will call s1 dot draw, then we will get drawing a shape, correct? Any doubt?
Sorry, ma'am, I didn't understand. That means circle does not have void draw, right?
Yeah, circle does not have void draw, but it has a default method coming from shape, right?
Okay, so default methods are called when it is not implemented in the inherited classes.
Yeah, right.
Okay.
So
So it would be drawing a
So
shape.
here, why typecasting was not required, ma'am?
typecasting for circle. See, when we have circle that implements shape, the circle will have access to draw method, right? It's kind of inheriting itself.
Correct, but in that case, earlier also we typecasted, na ma'am, that those sites, because right now it's an object of circle, but it
Hmm.
is declared as shape, so it knows itself as shape. Was that the reason S1 draw worked, or
No, no, no.
what if circle
Uh,
had its own draw method? Then S1 dot draw would have gone to circle's draw method,
Circles draw
or
method, correct. Yeah, yeah, yeah. That will happen with square now. Now square has its own draw method, right? So this will call drawing a square. S2 equal to new square, S2 dot draw will call drawing a square.
Does it mean that we have to typecast when there is a hierarchy mismatch or something?
Yeah, when the object contains some extra methods that is not in the reference type, There we have to typecast.
Okay, ma'am. Okay, thank you.
Ma'am, could you repeat that line? What you just said?
When the object type has some extra methods that is not present in the reference type, there we have to typecast. If circle has some extra methods that is not present in shape, then you have to typecast. That's what we have done, right?
Okay, ma'am. Got you. Thank you.
Yeah.
In most
Yeah.
of the cases, it is because of a hierarchy mismatch, I think.
We can call it as hierarchy mismatch. Yeah.
Yeah. Okay, okay, thank you.
Okay. Okay, we have reached 8 questions, right? So we'll go back to the concepts. Or week 2 doesn't have anything. I'll quickly go through this, okay? So in Java, we have seen class, hello world, main method. Then we have seen what each of these things, right? So this should be the starting entry point of our code. JVM will call this method, and we can't make any changes to this part. Only this variable name we can change. We have seen the scalar data types, primitive data types, int, long, short, byte, float, double, character, boolean. Okay, declaring the variables that you already know. Yeah, for characters, you should use only single quote. And the boolean variables are in small letter. If you make some variables as final variable, that is constant. And for float, you have to suffix it with f, correct? And also for long, you have to suffix it with capital or L or small l. Yeah. Then we have seen the operators, strings, string concatenation. And remember, strings are not arrays of characters. You have to use different methods to access the character. We have seen array, how to declare an array and all. Length attribute gives the size of the array. And for string, you have to use length method. That is the difference. We have seen control flow, if else, while, do while. Yeah,
Ma'am,
remember about the do while.
for quiz 1, we have to remember certain like methods. Like,
No, no. Um, if some new methods are there or unfamiliar methods, you will be given some description about what that method is doing.
okay, okay.
Yeah.
And if like the common methods, we have to remember all the arguments they take and what they give output, something like that.
Not much. I think you don't have to remember anything for Quiz 1 actually. Mostly those methods will be our own methods, like we'll give the code, right? So
Okay, okay.
except for println and print difference, you don't have to remember anything.
Yeah, okay, okay. Thank you.
Okay. Two kinds of for, one with initialization, condition, and implementation. The other one for each that kind of. Okay. Next switch. We have seen that.
Ma'am,
Here I want to concentrate. Yeah.
for a even if we declare something float, that f has to be suffixed at the end.
Yeah.
It's a little strange requirement because float we are writing no ma'am keyword on the left side, so but still that is
Just
there.
to understand, so differentiate between double and float, we have to do that. So we have two types for decimal numbers, right? Float and double.
Yes, ma'am.
So to differentiate float and double, we are suffixing it.
But in case if we wanted double, we would already write declaration as
Mm.
double, no? That is also there because
Yeah.
simply writing float will not make it a double, no?
Mm, Yeah, there also we will see that narrowing, right? To avoid that actually.
Okay.
So where is that? I think wait. Okay, yeah, I have it in. Hmm, this one. When you assign a smaller data type to larger data type, so we are specifying it. Okay.
That is automatic, right, ma'am?
Yeah. Okay, so from here, class and object. Yeah, class is a template for encapsulated type. Object is an instance of a class. We have class date, day, month, year. So this is a 3 argument constructor. So when you give a constructor, then will the compiler give a default constructor? What do you think?
Yes, ma'am.
So when you have a constructor, will the compiler give default constructor?
Yes, ma'am. And it will assign some sensible values to the variables that we declared. Like it
But
will assign 0 to the integers and all.
no. I mean,
If we
if
don't,
you have a constructor, how can there will be a default constructor? The compiler will
Huh.
not give.
Yeah, the compiler won't give.
Yeah, it will not be.
Yeah. So the compiler will give the default constructor only if your class doesn't have any constructors. Okay. Remember that.
I don't know in this context, ma'am, or somewhere
Hmm.
I heard
Hmm.
compiler will give a default constructor.
Yeah.
Uh, Maybe the
Only if.
case I am misplacing, but and
Hmm.
this int d m and y, let's say we don't specify, it will allot it sensible values like 0 and all. So I'm not
Yeah.
remembering
Yeah.
which context, but this is from lecture.
Yeah. So that happens only when the class doesn't have any constructors, zero constructors. Okay.
Okay, ma'am.
Okay. Then I'll just. We'll discuss here. Okay. So now we have a 3 argument constructor. Suppose we don't have a constructor, then what we are getting? So here you can't call like this. So this is going to call the default constructor with no arguments. Now get day, we are getting 0 for day, right? So how this is happening? So something called as a default constructor will be created by the compiler itself, and it will assign default values. For int it will assign 0, for decimal value 0.0, for objects it will assign null. Okay, and let's have this constructor. Okay, 3 argument constructor, and now I'm creating a date object without passing any values. Okay, now this is giving an error. Constructor date in class date cannot be applied to given type. So this kind of a no argument constructor is not present in class date. So once we have a constructor in our class, the compiler won't give the default constructor. So now if you want to create an object like this, what you have to do? You have to define your own default constructor, right? Okay, is that clear?
Yes, ma'am.
Okay. Now, instance variables, each concrete object of type date will have local copies of date, month, year. So new creates a new object. How do we set the instance variable? Using the constructor. We can say constructors as special functions called when an object is created. Function with the same name as the class. So the specialty of constructor is the name should be same as the class name, and it doesn't have any return type. And what is constructor overloading? Just what we have done now, right? So we have date with no arguments and date with 3 arguments. This is constructor overloading, just like method overloading. A constructor can call another one using this, that we can call another constructor using this. So this will call So what happened? So when you create this object D1 77890, so we came here, and here this is calling this particular constructor. So date is called. We are getting date is called.
Ma'am, sorry, once again, can you go back to that thing? I mean, so ma'am, when you calling out D1 get day,
Hmm.
where is it going? It's return day. Ma'am, line number 13 is going where?
Line number. Okay, here
Yeah.
this returning just the day what we have initialized 7.
Okay.
Yeah.
And ma'am, how did this get activated? Line number 7 get activated?
Yeah. Line number 7 gave a call to this default constructor.
No, I mean, who gave a call to line number 7?
Here, this particular line number 7 who gave call, because this is the constructor call, right? So here we have created, here we are calling the constructor, 3 argument constructor. When you create the object, and think it of like this is a method. Inside this method, we are calling another method. This is actually calling this constructor.
Ma'am, if you comment out line number 19, would date is called still be printed?
Yes, yeah. Because whenever this constructor is called, I will get this message.
Got it, ma'am. Thank you. Thank you, sir.
Yeah. So this point we have to remember all the time. If no constructor is defined, only then Java will provide a default constructor with empty arguments. only valid if no constructor is defined, otherwise need an explicit constructor without arguments. So what it will add is, it will add only default values, sensible defaults, like for int 0, etc. Same thing what we have discussed. That part is clear, right?
Ma'am, one doubt, ma'am. Suppose I have class A, I don't define any constructor for that. Then I put class B extends A. I define a constructor for class B. Inside class B, can I call super? Then will it call?
Huh.
Okay.
Then it will call the default constructor. Even if
Default.
you don't mention, still it will call the default constructor of the A class.
Okay. Okay. So
Yeah.
if I am not written, it will itself call the default
Huh.
constructor. Okay.
Right.
Thank you.
So next part is this copy constructor. So what is the use of copy constructor? We will create an object from an existing object, correct? So this one. So this constructor specialty is, it is going to take an object of date itself. So it is taking an object of date and then assigning the values for day, month and year according to the values that we have in D. Okay. So when you create this dot a new object by calling this copy constructor, the new object will get day value from the value that we have in D for day. Okay. Same case for month and year. New date, and what I am going to pass is D1. I am passing another object of date. D2 dot get day. So we will get D1 dot get day as 7 and D2 dot get day also as 7. We can also change it later. So I don't have a method to change. It's a private. So let me add. This day equal to D will also work. Here I will change set day to 8. Okay. So what we did here, after creating D2 from D1, I have changed the value of day to 8. So we got 8 here. So when you create an object using a copy constructor, you get a new object that will have the same value as the object that we used to create. Is that clear?
Yes, ma'am.
Oh,
Ma'am,
yeah.
here, is it possible, I mean, to show the ToString, I mean, the thing that we do with ToString, we devise override the object methods. I mean, will you be showing it today? I'm sorry, I'm not probably not being able to articulate it rightly, but will you be
You
showing?
want me to override ToString method?
Yeah, I mean, if we just print D1 and D2, we will be
Huh.
like D1 equals D2, D1 equal to D2, and D1 equals D2. That distinction, and we are changing it. We have to change equals to get the numeric values instead of the memory values, ma'am. That part, uh,
Ha,
if it's possible, ma'am. Today, I
yeah,
will not now. Maybe later on, also in the end, if that's okay with you.
yeah, I'll do. Anyway, we can develop this itself. So we want to compare two date objects, okay? In that case, first let us override the toString method. The signature of toString method is public string to string, okay? You can't give any other arguments over here, then it is not overriding. So here I am going to return day plus month plus year. Okay, now if I print T1, so when you print the object, when you print D1, this is going to invoke D1 dot to string, correct? So we will get day 7, month 7, and year 2025. Okay, so if you have not overridden this method from the object class, and then if you print D1, you will get this toString method that is invoked from the class object, where you will get the class name at symbol, then some hexadecimal code. Is that clear?
Yes, ma'am.
Okay. Then next is equals method, right? What is the return type? Public boolean equals. So what is the argument type? Object, right? It is object. Object some d. Variable name you can give anything. And here, how I want to compare is, I will take day, month, and year, and if all of them are equal, then I will consider those two dates as same. Return this dot d day equal to d dot day, and where is end? Where is end? Yeah. And this dot month equal to d dot month, and this dot year equal to d dot year. So if all of them are equal, then I'll get it true. Let's see if you get any problem over here.
Ma'am, will you comment out line 36?
Line 36, okay. Yeah, see here, we are getting an error. This dot day cannot find symbol, cannot find symbol, cannot find symbol. So what we have to do? What is the problem? What is the problem here? Problem is?
Conversion, typecasting we should have.
Yeah. So object, this D is of type object here. So we have to, if you want to access day, month, and year of a date object, then you want this D to be date, correct? So let's keep it like date temp equal to, you can typecast, right? Let's see whether, and we are using the temp. Let's see whether this is working. This will work. Why? Because whatever we are in this code, it will work. Why? Anyway, we are giving a date object, right? So no issues. Otherwise, you can also have a instance check, correct? After that, you can typecast. Sorry, if how to check whether something is an object of something?
D
Instance
instance
of.
Is instance.
Ma'am, not is instance. I think a instance of or like,
Oh, sorry. Yeah, I think that is Python. Huh.
date.
The instance of, it's not, it's an operator. So I hope this works. So as it is a single statement, you don't have to use curly braces. Anyway, we'll just add it here. Something wrong. Okay. What is the problem here? Our temp is declared inside if.
No, ma'am, you move this return this dot into that if condition. If it is instance of date, you check it. Otherwise, you just return false.
Hmm. Okay.
Yeah.
Here I'll return false. Okay, fine. Yeah.
The date temp also you can remove.
Okay. Sorry, this.
Date temp, yeah.
Yeah.
Ma'am, you're missing a bracket.
I think one more is needed. Okay, fine. So what we have done? We are checking this day, month, and year. And if we set this to 8, that should give us a false. Okay. Is that clear?
Yes, ma'am.
Okay. So that is overriding ToString and equals. This is very, very important, okay?
Ma'am, one question.
Yeah.
Equals compares the
The
memory
reference.
locations for non primitives.
Yeah.
But here this dot day, then this dot month, and this dot temp. Since we define them, I mean the day, month, and year as primitives, so equals are just comparing the numerical values.
Correct. They are just primitive ints, right? So they will compare the values itself.
But we can't use the equals if it's not if it were not primitives.
Right. Yeah.
Okay, ma'am. I don't want to go there. Thank you. I got it. This is enough for me. Thank you.
Yeah. So for string, there you will have problem. For string, if you use equal, it won't work, right? There you have to use equals method. So in that case, when you call the equals method while comparing two strings, it is actually invoking the equals method of the string class itself. There it would have already overridden to compare two strings, to compare the content of two strings.
Okay, ma'am. Thank you.
Okay. Okay, next part is just reading the input. We have seen it, right? You just create the object of scanner class, read using different methods. Next line, next string, etc. according to the data type. We'll go to next question. Is that okay with you? We have some more time. Okay. So this question is related to iterator. So interface navigator, we have boolean has next, and we have next method that returns an object. And here we have abstract class displayable having an abstract method show. Then we have class bookshelf, and it has an private class book that extends displayable, and it has string title and a constructor and a show method. Which show method? This abstract show method got an implementation here. Now we have another private inner class book iterator that implements navigator, this interface. Here it has a private int index, public book iterator constructor, has next, it will check if there is a next book. And then we have next method that returns the next book. Implementation is not given, just the uh, what specification of the method is given. Then we have get navigator method that returns a navigator type. Here actually it is returning an object of book iterator. Then we have our book array that contains new book, Swami, new book, Sampire, and then we have Palace. So this is the, you can compare it with linear list. Then this is our iterator. Here is our has next and get next method. Here is the public method that is going to return us an object of book iterator in navigator type. Here is our library test. Yeah, I'll take you out, okay? In main method, we are creating bookshelf, shelf equal to new bookshelf, this object. So we have this array in that bookshelf object. Then we have navigator, nav reference variable, and this is going to call shelf dot get navigator. So we will get iterator object in this nav variable. Okay. And then while nav dot has next, calling the has next method using the iterator, then something is here. If this is true, something has to be executed in line number 1. Identify the appropriate statement to fill in blank at line 1 such that the output is all these book names. Yeah. How the book is hinted?
Ma'am, why do you call it an iterator, and what is the iterator here?
So here iterator is this book iterator. This iterator has implemented the has next and next method that is implementing navigator. Navigator itself is just like our interface iterator.
Ma'am, by iterator you mean something that helps go through an array or a list or something like that. It is basically a kind
Right.
of a utility method, right, ma'am?
It's kind okay. I think you have missed week 4 lectures then. Why I discussed this is related to the iterator concept in week 4. Okay. So when we have something like linear list, or think it of this itself, this class bookshelf contain some collection, okay, collection of books, okay, and this is private, and our purpose is to loop through these elements of this particular collection, okay, and this is possible only through some iterator. And what we have is this iterator is a private class, and only this iterator can access to these elements of the collection, okay. And what we have is we have this has next and next method to get access to these elements, but this has next and get next method are present in the private class book iterator. And now when you want to get access to these two methods, what you have to do is, first thing, this iterator should implement a public interface, something called navigator here. And navigator is having this has next and next method. That is the method that we are going to implement in book iterator. So that is a connection. Okay. So we are going to have an iterator, and that iterator should implement a public interface called navigator, and it has two methods. One will check whether an element is present in the next position in the collection, and the other one is to retrieve that element from that collection. Okay. Has next, it will check if there is a next book in the collection, this particular array, and next is going to return the next book. Is that
Uh,
clear?
return the next book as in, ma'am, what do you mean? I get it that has next is checking for a book and return the next book as in.
Whatever that is here. So I want to print it. For example, I want to print the book over here.
Fetch the data of that book.
Huh.
Fetch the data
Yeah.
of the book. Okay, okay, okay.
Get access to that particular object.
So that's a getter. Okay, okay.
Yeah, yeah.
Ma'am, so if I understand this correctly, you are hiding the mechanism of this iterator and you are providing me two public methods, has next and next.
Correct. And we are so the iterator itself is a private class. So we are able to access this has next and get next just because it is implementing this public interface navigator.
I mean, there is no way that I can directly access that array of private book, the array books. I have to go through has next and next.
Correct. Yeah. For that, first you have to get this iterator object. Even this is private. Book iterator itself is a private class.
Okay, okay.
Yeah. So now to get book iterator object, we have this public method get navigator inside class bookshelf that is going to return book iterator object, and as it is implementing navigator, we are getting it in this reference variable. So here we have navigator nav, right? So using this is just like iterator it, so that will be easy for you to remember. So while it dot has next, we do that, right? In Python also. The iterator object we are getting here. So nav dot has next. While this is true, it is checking whether there is a next book or not. Then you have to get that particular book. So output should be this. Okay, how we are getting this? We are basically, if you see the show method is printing the title plus a comma. That is how we have the output, right? Title plus comma. So you also have to call the show method, correct? After you get access to the book, you have to call the show method of that book. Getting
Where
it?
is show method, ma'am? Which class?
Show method is in class book.
Okay.
Yeah. Why we have all this problem? Because this book itself is a private class. That you don't forget, okay? Class book is a private class. So that's why we had the problem of iterating through it from outside. For that, we have the book iterator, a private class. Now, once you get the book, you have to call the show method. That is the second part. First, you have to get access to this. From there, you have to call the show method. Now, if you see the private class book, this extends some public interface or class. Yeah, it extends class displayable. And this show method is actually an implementation for this abstract method. So now you have a way, right? You have access to displayable. Getting it?
Ma'am, what utility is displayable doing? I mean, it could have bookshelf could have directly had a display method. I mean, show method. No, it could have like what is.
So thing is, because this, that is because book is a private class. We cannot directly access show method or anything from private class book, right? But now, as book is extending the displayable public class, and the show method that we have in class book is actually an implementation for the public abstract method is show, we can access the show method and get the title printed. We cannot directly get the title or anything from this private class, but as show method is coming from the displayable abstract class that book has implemented, we are able to get access to show. Understood? If you're not getting it, I'll explain it again in the next session, okay? Because this is week 4. Just learn these concepts. Private class, you have to understand what is private class, okay? And controlled access to the objects of a private class using public interfaces or classes. That topic is very important that you have to learn. After you learn that, you will be able to understand. Remember, when you have a private inner class, none of the classes outside the outer class can have an access to the private class, which means only bookshelf has access to this private class. That is the first point. And how can you get a limited access to this private class? That is allowed only if this private class is extending or implementing some public interface or class and is implementing the methods that is coming from that interface or class. So in that case, you can get an access to methods like show or has next or get next from outside the class bookshelf, outside the outer class. Understood?
I'm sorry, I didn't understand, but I don't want to pause you here. Please continue.
Okay. So it's okay. You can just learn it. Okay. Just watch lectures or our live session. Second live session, I have discussed this one. Okay. Anyway, I will take it again. Just leave it for now. Okay. For who understood, I'll just give the answer. Anybody knows the answer for this?
First one, no ma'am. Displayable nav.next.show.
Right. This will be the answer. Why? Because
That
using
next is
nav,
returning object that you have to typecast it to displayable.
okay. And why displayable?
Because you cannot typecast it to book. It's a private class.
One more reason.
It is returning object. It is. That's
One more reason about show method.
Yeah. Okay. Yeah.
We want to access the show method, right?
Yes.
So that is coming from displayable. Yeah. I'll take it again. Leave it for now. So next one is related to copy constructor. I think you can answer this. I'll just explain the code. Okay. What will the output be? Class book, we have private variables, string title in price. Here we have the constructor, normal constructor, 2 argument, title equal to t, price equal to p. Then we have another constructor that takes book object itself, a copy constructor, initializing the values for title and price using the values from OT. Then we have set price that takes int p and set price. ToString method is overridden to return title and price. Class test, we have book B1, new book Java and 500, book B2 equal to B1. Now B2 and B1 both are pointing to same object. Okay. Now B3 equal to new book of B1. So we are creating B3 out of B1. Now B3 is a separate object that has the same value for title and price as in B1 and B2. Okay. Next line, B2 dot set price 600. We are changing the price value of B2. Will it have an effect on B1 or B3?
It will have effect on B1.
Correct. Because B2 and B1 as both are pointing to same object, if you change the price using B1 or B2, both are going to get affected because it's a single object. So print B1 and B3. So B1, what will you get?
Java 600. B3 will
Mm-hmm.
be Java 500.
Correct.
Ma'am, this one only shallow copy, deep copy, ma'am.
So here we can say this is a deep copy because
New book B1 is a deep copy.
huh. So this is a deep copy anyway.
Uh,
Why? Because in this particular class, we have variables of type string and int, right?
Hmm.
So even though it's like a shallow copy here, as this is string, it will create a new string anyway. And int also it's a primitive type. So yeah, it will be a deep copy, B1 and B3.
Thank you.
Yeah.
Ma'am, had
Yes.
B2 equal to be new book B1.
Mm.
I mean, I'm using a copy
Yeah.
constructor. I use it. Then,
Correct. Mm.
then the B1 would not have changed.
Wait. You said same, right? B3 equal to new book B1.
No, I'm saying B2
Mm.
new book B1.
Okay. Okay. Then that is a different object.
But B2 set price 600, then that would not have changed
Ha.
B1's price.
B1. Correct. Yeah.
That would still be 500.
Yeah. Then B1 will be just Java and 500. Only for B2 it will change.
Okay, ma'am. I think I got this. Okay.
Yeah. So if you're finding any difficulty in this, you just use a Python tutor, okay? You'll see how the objects are created and assigning values. This is a normal assignment, B2 equal to B1. Both are pointing to same object. And here we have used new keyword that itself is creating a new object, right? Only the thing is, it's a copy constructor, so the values only focus on the values that we assign to the instance variables. The values are from the object that we give here, the constructor. That's it. Basically, you're creating a copy of an object. Okay, see this interface printer. It has default method print, printing document. Interface scanner. It has a default method print, scanning document. Class multifunction device implements printer, comma scanner. Office test, main method, waiting object, calling print. What will be the output? Do you see any problem in this code? See, the interface printer has a print method. Scanner also has same print method, right? Multifunction device is implementing both of them. Now, how will we resolve the default methods, two methods that is coming from these two interface? What is the workaround?
By overriding in multifunction device.
Ah, right, correct. So we have not done that, right? So this will create a compilation error at line 1 because multifunction device inherits conflicting print methods and must override print. Hmm. So class employee, it has show method, employee show. Class department, it has, this is a get manager method that returns manager object. So here we have private class manager that extends employee. This is an inner class. And here show method is overridden
What is
from
the answer
employee.
from 11th one, ma'am? 11th one question.
This is a problem. So compilation error at line 1 because this particular class is inheriting print method from these two interface and the rule is you have to override that kind of conflicting methods. Only if you override the print method, then you won't be having any issues.
Okay.
Yeah.
So we have to have a print method defined in in that class multifunction increments printer. That will take care of
Right.
it. Okay.
Yeah. Okay. So this one, private class manager extends employee and is overriding the show method. So company test has main method creating an object of department. Okay. Department DPT is equal new department. Line 1 something manager obj dot show. So here we might have created some manager obj, right, in line number 1. So what is the choose the correct option for line 1 such that the program generates the following output manager show. So we have to invoke this show method of manager. So what we should fill in line number 1 to get that output? Again, this is related to private class. I think if it is difficult, leave it. Yeah, I'll just go with the next two. Okay, I'll take that later. Which of the following statements correctly describe interface and specification in a software components? This is a MSQ. What is interface? Interface includes function signature, argument, return type. Is that true?
Yes, ma'am.
Okay. Specification refers to the intended input-output behavior of the component. Correct?
Specification we have not learned, no, I think.
We have learned here also. I
No,
have
abstract classes and interfaces.
see here. Okay, this is a revision slide, right? You go to the week 1 slides. This part. Interface, what is visible to other components. Here you can see. Interface function header arguments return type. Specification is intended output input output behavior. This is a direct question from slides.
Okay, ma'am.
Yeah. So for the first week now, just go through the slides, just read it. Okay.
Okay, ma'am. But specification in details we have not seen, I think that.
No, not in
What is
detail.
it?
It's just like you can think it of like step by step comments on what
Okay.
that function is doing. So yeah. Interface helps describe how a component is implemented internally. Is it so? Does
No,
interface
ma'am.
helps you? Yeah. Next, a good specification language should balance abstraction and detail. Is it too related to interface and specification? So you
I
can
think
think
yes,
it of,
ma'am.
yeah, this is yes. So we should balance between. So interface is actually an abstraction, right? So it only shows the signature argument return type. Example in the functions, right? And the specification is that step by step instruction or something that we write. It shouldn't be very detailed, but it should be detailed. Like a balance should be there such that the developers can understand what the design specification is. So that's why good specification language should balance both abstraction and detail.
So why is option 3 not correct?
So here it is saying about interface is describing how that particular function or component is completely implemented. It's opposite of what is interface, right? Interface is equal to abstraction. So this statement is opposite of abstraction. Interface is hiding this details actually, the internal details, implementation details.
And what do we mean by component here? What are the things?
component, you can think it of like function or classes itself.
Okay, it could be methods, functions, class. It could be either any of
Huh.
them.
Yeah. This one, which among the following statements is or are true about activation record? Multiple activation records of the same function can exist on the stack during recursion. Is it so?
Yeah, if it's the same it's being called multiple times. No?
Correct. We have seen this for factorial, right? We have seen the recursive call for factorial, and one after other it will stack up. So multiple activation record of same function factorial we have seen, right? Same thing. Next, activation records created for functions are allocated in heap.
False.
Okay. Next, the return value link in an activation record.
Ma'am, number two, activation records are created in the stack, right?
Yeah, right.
Okay.
So activation records are created in the stack. So the second one is wrong. The return value link in an activation record identifies the memory location for storing the function's return value. Correct or wrong?
Correct, no, ma'am.
Yeah. So
Ma'am,
return value link is to store return value. Yeah.
please explain this, ma'am.
So in activation record, one component, one part is return value link that will actually connect to the place where you have to store the return value of that particular function call. You can think it from the main function you are calling some add function. Okay, just two functions now we have: main function and in this I am calling add function by giving int some 5 and 4 and 5. Okay, now this add function, for this add function we will have an activation record and that will have a return value link, right? That return value link, so for example if I'm calling a equal to add, so that will point to this particular place where it has to return the value of this particular function. So return value link will point to the place where it has to store the return value of the function. Clear?
So the return value link is to A, the memory address.
Yes, to A, to line number 2 of this particular code.
Okay.
Yeah, this has something internally it is different. Okay. Yeah, anyway, you can think it of like it is going to point to this line number 2.
So we can say return value link and control link is same, no?
No, that is different.
Yep.
Control link is actually to return back, like to connect the function calls. So in the same example, I can say it like if it is not
Oh,
returning
understood.
anything.
From where it is
Okay.
being called. So control link is
Right.
for that. From where it
Yeah,
is being called. Okay.
correct. So here, the lifetime of a variable extends beyond the removal of its activation record from the stack.
No, false, no, ma'am.
False. It's a false. So once we remove the activation record, a variable lifetime is over.
But had it been heap instead of stack, would that have been true?
Yeah, right. So this is related to ToString method. You try to solve it. Class author, it has string name, private variable, constructor, ToString method. It is returning authored by the name. Class book, here we we have title of type string, then author, an object of author, constructor, title equal to T and author equal to A, then then we have code segment here, class library, main method, author, creating author object by passing RK Narayan, and then we are creating book object by passing this title, Malgudi days, and author object, this one, and finally printing book. Okay. Choose the correct option to fill in the code segment so that the output is Malgudi days authored by RK Narayan. So we have to have code for this code segment, which is ToString method, right? And it should print all this. What do you think? Will this work? ToString title plus author dot ToString. So in book, okay, we are actually defining it in book. Title will get here, and for title Malgudi days, and we want to get this authored by RK Narayan. For that, plus taking the author object and calling the ToString of author. Will it work?
It
Yes,
will
ma'am.
work, ma'am. It will work.
Yeah, this will work. And next, public string ToString, taking author object and then returning title plus au dot ToString. What about this?
Does the constructor take author object, ma'am?
So you are saying ToString is taking author object, right?
But AU is not the object created of author, ma'am, so it will not work. AUTH is the object.
Thing is, here this is going to be a different ToString method itself, an overloaded ToString method that is taking an argument. This won't override the ToString method that we get from class object. So that is a problem. So that ToString should be in this particular format, this signature, public string ToString. You can't change this part. Clear?
No, overriding we could have changed, ma'am, but problem is author RK Narayanan has been created using name AUTH, not just AU. So maybe book can have a ToString method overridden with this accepting author object, but
Yeah.
instead of AU, it should have been AUTH. Then this also will work.
No. It won't work for our case. So when you print for this statement for system.println book, this should invoke book.toString, which should be of this form, not this form, right? So we want to get this to be printed. For that, a ToString method, a normal ToString method that we get from object, that should be overridden. Because
Correct, ma'am.
this println,
we have to fill this code in the book class, right, ma'am?
yeah.
So nothing is stopping me from writing my own ToString method, no, with which is accepting the author, which is already created.
But
So
you
I'm
could
saying
have called it here, right? Otherwise, we won't get the output in this manner.
no. Once it is overridden, it needs to be explicitly called. Is it like that, ma'am?
Yeah, but we can't do that, right? We just have place to fill this code segment and
Correct,
get
ma'am. So
this
if this
output.
code segment is instead of just plain ToString, if it is a overridden ToString, it is still fine, na, ma'am? No.
Without this argument. No. With this argument, it won't work because here, this book, while printing this book, this is going to invoke ToString without any arguments. That is the default way. This
Okay,
will
ma'am.
not call this particular overloaded one. ToString method with some argument. It won't call that by default.
Okay, ma'am. Okay, so we can have three ToStrings with overloading mechanism.
But you
And
have
then
to
we
call
have
it
to
explicitly.
separately. Okay.
Yeah. Next here, ToString method again. Third option. You check the third option.
Yes, ma'am. This will also work. But author's ToString, can you show us once?
Yeah,
Yes, ma'am. This will also work.
correct. This will also work. What about next one? Title plus author dot name.
No, this will leave the authored by uh, words. Authored by
Uh,
words will be left out. So
what if we have authored by?
no, authored by words are written in the author's ToString, na ma'am. So here we are just writing title plus blank and then author dot name. So only RK9 will come. Authored by RK9 will not come. That's why this fourth one is wrong.
Will Arkanarayan come? Look at
I
variable.
think so, ma'am.
It's
Name is
This is
that.
private, ma'am. It won't come.
this is private, right? So it won't come.
Okay.
Yeah, it will give a compilation error because name is not accessible
Understood,
in
ma'am. Correct.
book. Yeah. Okay. So I think I'll take the rest next. Maybe you guys are also tired. Okay. So fine. I'll come back with the week 3, 4, and PYQs. Okay.
Ma'am, we didn't see anywhere protected, no, ma'am.
Week 4 we have seen, right? In access modifiers.
Oh, I think I have. Okay, I will check again, ma'am.
Yes, very briefly, ma'am. Not, I think it's
Detail.
just mentioned in slides.
Okay. We'll discuss this. Okay.
Ma'am, if you can please mention briefly about public, protected, and private. So, which one has got more power?
Yeah. So we have public and no modifier. We would have seen, right? We define classes with no access specifiers. So we can call it as no modifier or default. It's not default, okay? Not the exact keyword. I'll add one word D. And then we have protected. Then we have private. So this is the order. So public has the highest visibility. No modifier, next. Protected, next. Private, last. So I think you won't be having any confusion about private. When you declare variables or methods as private, it is accessible only inside that class. And for protected, if you have a class A and if it has protected int variable, and if you have class B that extends A, okay, here you see this. If this is a private variable, can be can be access variable var?
No, you
No.
cannot access. Yes.
No. But for protected variables, class B can access protected variables of superclass. Okay. Now, uh, okay, you will see. Okay, I think this much information is fine for now because package and role we have not discussed, right? So you will get more confused. For now, understand this. If you have a class A and if it has protected variables, any subclass that extend that particular class can access the protected variables. We have,
Directly without the object, ma'am. Like how within the class I can access that.
yeah, within the class you can access.
I
If you
mean,
have some method or something, some method if you have,
ah,
you can access here.
super dot.
It's like on variable. Here you can access.
Very well. Oh, directly like that. Okay.
Yeah.
Okay. Okay. Thank you, ma'am.
Okay. For now, understand this much. Once we discuss about package and all, I'll talk about the difference between no modifier and protected. Okay, public you can access anywhere.
When is the next session, revision session?
It will be on Friday. So tomorrow, TA session will be held on tomorrow. Okay, so we have preponed it. Join the session. Okay, here we'll also be discussing about some questions and all. That will also be a revision session.
Sorry, ma'am. Tomorrow's session preponed as in like.
Thursday's TA session is rescheduled to tomorrow, Wednesday.
Okay. Ma'am,
Yeah.
is it possible to take a graded assignment, week 4 graded assignment question now?
Yeah. You can. 1 second. Let me stop streaming.
So
Ma'am,
tomorrow same time, ma'am.
ma'am, if you let it on, it would be great. I mean, we could always refer back. I mean,
Tomorrow 6. Yeah. Anirban, yeah, you can share your screen.
1 second.
Or